now a numerical on the periodic and aperiodic rhythms. The question is, determine whether the following signals are periodic or not. If periodic, determine its fundamental period. So this is the question given to us. There are 7 questions in that, and let us see one by one category wise whether the given signal is periodic or aperiodic. So look at the first one. The question given to us is cos 0.01 pi n. So I already told you, according to the theory, that if the frequency, if it is rational for this kind of signals, then the given signal is said to be periodic. So let us compare this signal with 2 pi fn. So just comparing with 2 pi fn. If the frequency, if it is in the form of a p by q number, if it is a rational, then it is periodic. Let us see whether it is periodic or not. So 2 pi fn is equal to 0.01 pi n. This pi and pi and n will get cancelled. Then I got frequency is equal to 0.01 by 2, which is nothing but 1 by 200, which is in the form of k by n. So therefore the given signal is a periodic signal, and the fundamental period of this signal is the denominator term. We have 200 here, so therefore the fundamental period is 200. Now look at the second question. E to the power of j pi by 4 n. So we have to apply here Euler's identity. This will become cos pi by 4 n plus j sin pi by 4 n. This is of the form combination of two signals. So we have to compare with 2 pi fn for the first signal and 2 pi fn for the second signal. We will get the first frequency term, fundamental period term, and then here also we will get the second frequency term and fundamental period term. If the ratio is in the form of n by m, which is rational, then the given signal is periodic. Otherwise, the given signal is aperiodic signal. So first compare. If you look at the two, both are same. 2 pi cos of 2 pi fn or sin of 2 pi fn. So we will get the same value for both. So I am checking for only one here. 2 pi fn is equal to pi by 4 n. N will get cancelled. Pi and pi will get cancelled. So f will be equal to 1 by 8. So the frequency which I know just now is 1 by 8. It is nothing but frequency is equal to 1 by time period. So I got fundamental period n1 is equal to 8. Similarly, I will get n2 also is equal to 8. So ratio will become obviously rational, and therefore the given signal is periodic, and the fundamental period is LCM of 8 and 8, which is again 8. So I got n is equal to 8. So this is the first category where the frequency should be in the form of p by q, rational number, and this is the second category we have discussed, combination of two signals, t1 by t2 or n1 by n2 should be a rational number, and the LCM here is LCM of t1 and t2 and n1 and n2 in this case is the fundamental period, capital N or capital T. In this case the denominator time itself is the fundamental period. Look at the third question given to us. Cos 3 pi n. So 2 pi fn is equal to 3 pi n, pi and n will get cancelled. F is equal to k by 2, which is in the form of k by n, and the fundamental period is 2. Very easy question. So from this, what is our understanding is, wherever there is a term pi into n or pi into t, signals are going to become periodic. If there is no pi term, signal is going to become aperiodic in some cases, not in all. So coming to the fourth, sin 3n, there is no pi term here, so directly I can say it's aperiodic, but let us see. 2 pi fn is equal to 3n, n and n get cancelled, f is equal to 3 by 2 pi, which is not a rational number, so therefore it is aperiodic signal. That's why I said if there is no pi term, we can conclude it's aperiodic, but 95% signals only it is correct. For the rest of the 5% signals we cannot say. So it's better to calculate and decide whether the signal is aperiodic or periodic. Now coming to this fifth one, cos t plus sin root t. There is no pi term in both, either in this or in this. So what could be the guess? It's a periodic or aperiodic? Let us see. So compare with cos 2 pi f1t plus sin 2 pi f2t. 2 pi f1 t will be is equal to t, t and t will get cancelled, f1 is equal to 1 by 2 pi, that is equal to nothing but 1 by time period, so time period t1 is equal to 2 pi I got. Similarly, time period t2 I got it as root 2 by 2 pi, the frequency which we got is root 2 by 2 pi, so the time period is also of the form, there will be root 2 and pi term is available in that, so this is a rational number and the second signal is not becoming periodic. Even though first is periodic, second is not becoming periodic. So the overall signal is a periodic signal. We can say that it's a non-periodic signal. The sixth one. Cos 100 pi t plus sin 150 pi t. Similar to this, but here we have pi term there. So maybe chances are there it will become a rational number. Ratio will become rational. So compare 2 pi f1 t plus sin 2 pi f1 t. I am comparing with x of t is equal to cos 2 pi f1 t plus sin 2 pi ft. So I got it as 2 pi f1 t is equal to 100 pi t in the first one. T and t will get cancelled, pi and pi will get cancelled, so f1 will become 50, which is nothing but 1 by time period, so time period will become 1 by 50. Similarly, second one will get time period is equal to 1 by 25. Because we have only 50 term here, we will get instead of 1 by 50 we will get 1 by 25. Same procedure. Compare it with 2 pi f2 t. So t and pi will get cancelled. f2 will become 25. That is nothing but t2 will become 1 by 25. So if you take the ratio t1 by t2, it will become 1 by 50 by 1 by 25. That will become 25 by 50 is equal to 1 by 2. So it is rational. So the given signal x of t, which is a combination of these two, and cos 100 pi t plus sin 50 t is a periodic signal. And coming to the fundamental period will be LCM of t1 and t2, that is LCM of 1 by 50 and 1 by 25, it will be 1 by 25. So fundamental period is 1 by 25 in this case. And coming to the last signal, 7th one, e to the power of minus j 2t. Apply the Euler's identity, it will become cos 2t minus j sin 2t. There is no pi term in both cases here, but this is going to become a periodic signal. Let us see that how. So 2 pi f1 t is equal to 2t. The first signal is having 2t. So t and t will get cancelled. f1 is equal to 1 by pi. 2 and 2 also get cancelled. So f1 will become 1 by pi. Therefore t1 is pi. Similarly, the second signal is same 2t only. So 2 pi f2 t is equal to 2t. 2 t will get cancelled. f2 is equal to 1 by pi. t2 is equal to pi. So finally the ratio t1 by t2 is equal to pi by pi, which is 1 by 1, which is a rational number again. So the given signal is periodic signal. Even though there is no pi here in this question, signal became a periodic signal. So there are rare cases like this, the signals may become a periodic. So don't jump to a conclusion that if there is no pi, the signal is a periodic signal. And coming to the fundamental period, that is LCM of pi, it is pi only. So fundamental period is pi. So like this, we can calculate whether the given signal is periodic or aperiodic signal.